Hi guys, this is Uberi. Welcome back to my channel. In this video, we are going to cover Advanced Spark and PySpark Interview Masterclass. We're not just going to cover syntax, we're going to dive into how we solve the real world problems. Basically, interviewers care about your thought process. So we'll take some scenarios specific in the real world. So we provide a detailed code examples and visualize those solutions. Okay, so that you can get ready for your next interview. So in the first scenario, we're going to see about skewed data. Your Spark job is slow. What will you do? Skew happens when one partition gets too big. Sorting is the key. In this example, we generate a random number from 0 to 9 and suffix it to our join key. We do this on a large table. When we join, the big partitions gets distributed. Then we aggregate grouping by the original key to collapse the sort back down. This balances the workload. In the next scenario, we see about the small file problems. Yes, thousands of small files are killing the performance. This creates too much metadata for HDFS and overhead for executor. We consolidate them, we read that many files, then use a coalesce to reduce the number of partitions to reasonable target count, say like 10 or 20, depending on the data size, without triggering a full shuffle. Then we rewrite it back out. If we need a larger partitions count and a shuffle, we use a repartition. Next scenario, we have like join optimization. How do you optimize joins? They may ask these queries like this, but we can inform them saying that we use multiple techniques. First and foremost, the broadcast join and a hint for small tables, which avoids the massive shuffle of the big table. Second, choose the proper join types, like an inner join to discard rows early. And the third is we use a proactive partitioning strategy like bucketed by on a common join keys, which aligns data and can turn shuffle intense operations into a direct move. In the next scenario, we have how are we handling nested JSON. API data with deeply nested JSON. The solution is structured schema and explode. First, we define a precise schema that matches the nested structures perfectly. We use from JSON with this schema to parse the data, and then we use explode function sequentially array of columns, flattening the hierarchy. Here we do that because we explode the user's item array, turning one row with many items into multiple rows with one item each. Next scenario, we have memory issues. So what is this executor's memory error? An out of memory error means you are trying to fit too much into an executor's RAM. We solve this by turning configurations like spark.executor.memory. We decrease partition size by increasing spark.sql.shuffle.partitions, giving a smaller chunks to each executor. We persist intermediate dataset wisely using a balance like memory and disk serialization only when data is used multiple times, and always unpersist immediately after we finish with that specific data set. These are some of the configurations which we set in the Spark. Moving on to the next scenario, we have incremental processing. Generally, how will you process only a new data? This is the key for efficient ETL. One powerful method is using a structured streaming, watermarking to define how long to wait for late arriving events. Another is utilizing a delta-lex merge command. We select new data from a source, compare those data with against the delta table using the timestamp column, and use conditions to ensure we only update or insert newer records. This effectively implement a CDC-like approach. CDC is nothing but change data capture, similarly like SCD, a normal ETL word. So you might have a query like when do we use a Spark versus SQL? Like in which scenarios we use Spark versus a traditional database? A traditional database like Postgres or MySQL is a perfect for ACID compliant transactions, complex updates, and standard business applications where data volumes are up to a few terabytes. We choose Spark when the data volume exceeds a single machine or a cluster capacity, the true distributed case, or when the transformations are too complex to express in SQL, such as machine learning, complex graph analytics, or processing massive unstructured log files. and image processing. Then we move to Spark for scale and complexity. So in summary, for PySpark interview means thinking in a scenario based. Master this some of the specific scenarios or areas, dig deep into them and get in details, understand the why behind your choices, and you will stand out. Don't just memorize functions, practice with real data, okay? Build your pipelines, break them, fix them, repeat, so that you get to know what kind of errors you might be facing in between those pipelines, and so that it will be more easy to answer those queries in the when the interviewer asks those. So good luck in building something and breaking it, and then fix it, and you'll be interview ready. So I'll come up with the next video. Until then, take care. Bye bye. This is Berry signing off.